Hello, welcome back to the course on audio signal processing for music applications. We have been talking about sinusoids since the very beginning. Sinusoids are at the core of what we will be doing. In this week, in the DFT, sinusoids are part of the DFT, and in order to understand the DFT, it's fundamental to understand sinusoids. So in this class, I want to teach how to program sinusoids, how to code sinusoids. And in particular, we will be playing around with two types of sine waves. The real sine wave, which is a sequence of numbers, in real numbers, that can be computed by calling this function. So it has an amplitude, capital A, and we can call the function cosine with an argument which is 2 pi with the frequency and the time index. N is a time index without a discrete, and then the capital T is the sampling period, and then we have an initial phase. And then we will also compute a complex sine wave, the ones that appeared in the DFT. These are complex sine waves that are discrete, and they do not have any time information. So it's just with an index n, and the frequency is an integer value. So these complex sine waves are always periodic for a given capital N. So we define a capital N, which is going to be the size of the DFT, and then these complex signs are always have a fixed number and of periods within that n, and this depends on k. So in fact, k is the number also of periods within that capital N. So to write some code to implement these sine waves, we need to open up a text editor, in this case gedit, and we can start typing Python commands that then will be part of a file, will be a script that then we can execute using Python. Okay, so we first need some packages, and typical packages that we will always need. One is the library for plotting, matplotlib, particularly pylab, and we will call it PLT. Then we will always need NumPy, and this will be our package for playing around with vectors and arrays. Now we can start typing code, so defining the sinusoid, the real sinusoid. So the real sinusoid has an amplitude, and let's define an amplitude of 0.8. It has a frequency, let's say f0, that in hertz, let's say 1000 hertz. And it has an initial phase, phi, let's say pi over 2. Pi is a variable defined in the NumPy package, so that's why we put np.pi. And now we need the sampling rate, because we need to compute the sampling period, or we need to display the real sine wave in time. So our typical sampling rate will be 44,100. Okay. Now, since we do vector operations for the time index, we will define an array, and we will be using this function arrange from NumPy that allows us to define a range of values and an increment, and then automatically it computes all the values between these two limits. So this will be an array of floating point numbers going from minus 0.002 to 0.002 in the increments of 1 over fs, or capital T, which is the sampling period. And now we are ready to compute our function. So it will be amplitude A times cosine, and in the argument will be the 2 pi, so 2 times np.pi times the frequency, okay, times the time index, which is the T array, and then we need to sum the initial phase phi. And it will be our time function, our sinusoid. And in order to plot it, what we will do is to plot the time array with respect to the x values. And a good practice is to define axis values. So for example, in this case, the axis in the horizontal axis goes from minus 0.002 to 0.002, and in the vertical axis will go from minus 0.8 to 0.8. Okay, this will define the axis of what we are seeing in the plot. And then also it's good practice to label the axis. So we need to label the x axis with an x label, and the x label will be time. Okay, and then we need to label also the y-axis, so with the y label, and that will be amplitude. Okay, and that's it. The only thing left is to call the show command so that it will display. And hopefully, if I didn't type anything wrong, it can be computed. So we save it under name sine.py. Okay, and we can go to the terminal, and here we have the sine.py file, and we can execute it by typing python and sine.py. Okay, it gives me an error that says that okay, I typed wrong the name of the package. I had to type pyplot, not pyplot. And now that I see also the cosine is wrong. Cosine is a function within numpy, so I have to put np.cosine. Okay, so 2 bugs already. Let's execute it, and now it's okay. Okay, we have a sinusoid. We have the time in seconds, the horizontal axis. Time 0 is in the middle, and the amplitude is in the vertical axis. And so we have 4 periods of this sine wave. Okay, now let's go for the complex sine wave, which is going to be a little bit more complicated. The packages are going to be the same, so let's type it here, so we might be able to reuse some of this code. So the first thing we will need to do is to define the variable capital N, which is going to be our array length, or sort of like in the case of the DFT, the size of the DFT, and let's say it's 500. And the frequency is going to be an integer, so let's say k equals 3. And then in terms of the index, in the time index is going to be integer values. So it's going to be, and we can just easily just say np arrange, and we can display it from minus n over 2 to n over 2. Okay, that will be the time indexes that will be created, and now we are ready to compute the complex sine wave. So the complex exponential is a function that exists in numpy, so we just say np.exp. And now in terms of the arguments, for j we just say 1j, then it's 2 pi, so 2 times np.pi. Then we multiply by k, we multiply by n, and we divide by capital N. And that's our complex sine wave. And in order to display it, well, we cannot display the complex in a 2D representation. So what we will do is we will display, well, n and against the real part of S. So in order to do that, we will say np real, and we will get S. Okay, and this will display the real part of this complex sine wave. And now again we might want to have some specific axis labels. So the axis will go in this case from minus n over 2 to n over 2, in this case minus 1, because 0 is also one of the values. And then in terms of the vertical axis, we just say from minus 1 to 1 because it's normalized to 1. Okay, and then for the labels, the x label, we will say that is just the n indexes. And for the y label, the same thing, we have the amplitude. Okay, and that should do it. The only thing left is again the show command, and that should do it. So if I delete this other part and I save it under the same name, so it's the sine. Hopefully, if I don't have any error, okay, it displays the real part of the complex sine wave, which is a cosine, so at time 0 is 1, and it has exactly 3 periods, which is k. K specified 3, which means 3 periods within this capital N. Now, if instead of the real part, we want to display the imaginary part, can compute again, and this is the sine part. So at time 0, it's a sine wave, and it's 3 periods of the sine function. Okay, so in the DFT, what we're doing is for different n's. So in the case, the n is the DFT size. So for example, let's change the n, let's put 32, for example. And then k is one of the sinusoids of the DFT. So for example, let's put number 5. So let's close this, and if we execute this will look a little bit different. Okay, so this is much fewer samples. It's only 32 samples, and there is 5 periods of the, in this case, the imaginary part of the sine wave. But of course, we have few samples per period, so that's why we see it so jagged. But anyway, this is a computed sine wave, and is the kind of sine wave that we will be using in the DFT. And that's basically all I wanted to say. So we have been, in this class, we have been talking about sine waves, and we have been explaining how to code them using Python. Specifically, we needed 2 packages, NumPy and Matplotlib. NumPy is going to be a fundamental package for handling all these arrays that we'll be using, and Matplotlib will always need it because we'll always be plotting things. And that's all. So this was the first programming lab, first lecture in this second week. So in the next programming lecture, we'll go into the DFT. So we will go into how to program the complete DFT. Sinusoids is one part. Now we'll put it together into programming the DFT. So I hope to see you next class. Thank you.